Today's episode is sponsored by Symani, the Cybersecurity Manufacturing Innovation Institute. Visit them at symani.org.
Aerospace and defense manufacturing.
Machines and automation.
Additive manufacturing.
Smart manufacturing.
Global manufacturing economy.
Welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals, powered by SME. From the design screen to the shop floor to final assembly, we drive the conversation about making manufacturing smarter by connecting people who are passionate about manufacturing.
Hello, and welcome to Advanced Manufacturing Now, the podcast for manufacturing professionals. Don't forget to like and subscribe to get new episodes delivered to your feed each week. I'm your host, Steve Plum, Editor-in-Chief for SME Media. I'm joined today by Howard Grimes, the CEO and founding member of Symani, which is short for the Cybersecurity Manufacturing Institute. Symani was founded in 2020 as part of the Manufacturing USA network of organizations. Of course, cybersecurity is more important than ever, especially for the manufacturing industries, which is one of the main targets, unfortunately. So, Dr. Grimes, welcome to the show.
Thank you, Steve. Happy to be here.
So before we jump into the main topic and get into what's going on in terms of cybersecurity across the manufacturing sector, can you tell us a little bit more about yourself?
Yeah, so I'm Howard. I served as the principal investigator for what is now known as the Cybersecurity Manufacturing Innovation Institute. We've been funded by the Department of Energy via Congress. And the RAMI Act, Revitalizing American Manufacturing Innovation. In such, we are focused on, the cybersecurity of both the manufacturing processes and, very importantly, their supply chains. My background is long and a bit varied. I started off as a biophysicist and moved into areas of protein physics and protein structure and function, which got me into at a very early age, and when it was a very young field, into what is now known as big data. So I learned a lot of how to do that work, and then as I did that work, the security aspects became more and more important, and so I morphed myself into, someone who knew something about not only data, but how to protect data at rest and in motion. And then ultimately, that led me to where I am now, which is I consider to be the most important job I've ever had in my life. I spent a lot of it in academia, served as a dean, served as a vice president for research. But again, the mission that is in front of us now, both, in terms of manufacturing, but cybersecurity writ large is huge and vastly important. The threats are obviously present. The threats will continue to grow, both in volume and in sophistication. So when I say it's the most important job I've ever had, that's part of what I mean by that.
Well, definitely an interesting and diverse background and experience. I wonder if you could share a little bit more about your past experiences with data and analytics and kind of the overlap with that on cybersecurity and what you've learned from the past, how that affects what you're doing now and how your team is working to address cyber issues.
Well, I think at the end of the day, what is now called big data is exactly that. It's big data. While we have, names like big data available today, 20 years ago, people like myself were thinking about data and at scales that were previously not possible because, computers didn't exist. Storage of data, was not really possible except in analog devices or notebooks. And so as our world transitioned, it really forced a lot of us to think hard about, how we would, do analytics on big data, how we would glean from big data what we now call actionable data, what's important versus what's kind of noisish, and how do we do that? And I've been pretty much involved in that, as a scientist, if you will, from throughout that evolutionary pattern. And so how's that informed me today? I think that basically it's positioned me in a very fundamental way to really think at fundamental levels, as opposed to dropping, parachuting into the current world and trying to develop what we would think of as a bits and bytes approach to cybersecurity. I tend to think in a very holistic and integrated manner, have my entire career, which is fundamental, I think, to what, what we do at Symantec, at the Institute, and frankly, what differentiates our approach from, almost everything that is available today.
So cybersecurity is obviously a very broad topic that literally affects everyone every day. What is the focus of Symantec and, the kind of the big picture mission statement?
Yeah, so I think the fundamental challenge facing cybersecurity in 2025 and beyond is that, the threat vectors, the attacks, like I said, are continue to grow in volume and in sophistication. I think what we responded to incredibly effectively was understanding early on that existing approaches to cybersecurity were not sufficient in order to address current cybersecurity threats, but most importantly, where cybersecurity threats are going in the next, many years. Like I said, the threat is here. The threats will continue to grow over time. And so what differentiates Symantec is that we literally went back to the fundamentals, the fundamental science, fundamental mathematical principles, fundamental physics, and really dissected, the problem set in a way that other folks have not. The current state of the art is, how do you keep the bad actors out of your network? I mean, this is what we call perimeter defense. There are multiple ways to achieve it, and most, if not all, are simply, they won't work. Most of the companies, most of the manufacturers that have been breached do, in fact, have some level of cybersecurity protections in place, and they get breached. It's a matter of the simple fact that the current approaches are not sufficient. And so what we want to do is we want to think about what is sufficient and what's necessary. And so we, like I said, we really roll up our sleeves. We get into the fundamental mathematics and mathematical physics of understanding the problem set, and thus being able, to introduce innovative cyber defense capabilities that just literally do not exist today. And so that is really the paramount in our mission. We want to innovate and develop new technologies and partnerships to secure America, but we do that by being the most innovative cyber defense team in the world.
So you mentioned taking a mathematical and scientific physics approach. I never really thought of it that way. Can you elaborate more on what you mean by that?
Yeah. So essentially, if you look at cybersecurity today, the common protections that people use are, well known, right? Install a firewall, get an air gap built into your systems, do endpoint analysis to see, and there's even, preemptive, figuring out where the threats may be coming from, and trying to mitigate those to the extent you can. But basically, all of our cybersecurity strategies are very reactive. Very few are proactive. And so what we mean when we say fundamental mathematics, there's fields of mathematics that are very useful for understanding, how the threat vectors are evolving. We can validate the mitigative steps that we take in ways that were not previously possible. We can quantify the impact of our innovations, and again, in ways that, other entities are simply not able to do. So you really have to break it down into what we call a system of systems approach. And you also need to understand, especially from a manufacturing perspective, what is the elements that are unique to manufacturing. Essentially, there's several things that make it unique, but paramount on that list is that, when you think about cybersecurity for most industries, financial, the health sector, et cetera, you're basically dealing with, data, right? Acquisition, breaching of data, using data in ways that, are not intended. But in manufacturing, there's another element, and that's the fact that there are processes involved. They're physical processes. We call these assembly. You can talk about roll-to-roll manufacturing. Any kind of process that you use can be disruptive via cybersecurity attacks. And so we need to use a system of systems approach and a cyber-informed engineering approach to really understand, what's possible in that arena. The other thing that's unique about manufacturing that I think people will begin to understand in the future is that a lot of manufacturing processes, as I just mentioned, are what we might term highly contained but exothermic reactions. Exothermic meaning thermal, and it goes boom, right? It has the potential to cause great harm to not only facilities but the people in those facilities. And so we really need to think, when we think about cybersecurity for manufacturing, we make a transition from IT, information technology, to OT, operational technology. We then start to think about, what are the integrated control devices? What are the networks that control, the processors that control these manufacturing processes, and what unique properties of those, again, at the fundamental system of systems level, what are the fundamental properties that will allow breaches to occur that might not be able to occur, in a traditional IT cybersecurity environment, like, again, financial or data like you find in a health environment. So I believe, very strongly that you have to think hard about not only the physical plane, the cyber plane, but also the process plane that's up above that, and how do we integrate those in terms of protecting and securing U.S. manufacturers.
Can you talk a little bit more about how things have changed in recent years? Maybe for a manufacturer that was predominantly Industry 2.0 to Industry 3.0 and now Industry 4.0 or even 5.0. What were some of the main threats, 5-10 years ago versus today, and where do you see that evolving to?
Well, I think the fundamental threat is, as we move into, Industry 4.0, right? And what we mean by Industry 4.0 is when you start to connect people with machines and the data around that. And so as you digitize your processes, and most manufacturers, a little known statistic, I think, is that manufacturers are leading the world in digitizing their environments. And the reason that they're leading the world in digitizing those environments is that that digitizing your manufacturing processes leads to dramatic increases in productivity. And so manufacturing is all about producing parts and products and items. And as you do that, if you can increase the productivity, you increase your efficiency, you increase your profit margin, all of which is, by any standard metric, a positive thing. So manufacturers are highly incentivized to digitize their environments, to move things on, from analog controls to digital controls, et cetera. And so as they do that, though, there is that unintended consequence of they exponentially grow what we would call the cyber security attack surface. And so, every time you install a new processor, you digitize a data flow, you exponentially increase your vulnerability, your cyber vulnerability. And one of the things that's just evident today is that our vulnerabilities are growing at such a high rate that, again, current approaches to cybersecurity are simply ineffective. So, one of the things Symantec is doing is, going back and asking fundamental questions about how do we change our entire approach from, vulnerability detection and mitigation to cyber weakness enumeration, detection, and mitigation. And so we're able to think about how to capture thousands of vulnerabilities into single weaknesses that then we can build, and we've built these at Symantec. We've built Symantec-specific attack annexes so that we can model the cyber attacks against those new digitized surface areas that are vulnerable to attack. And we can then use multiple techniques, including artificial intelligence, to maximize the impact of detection, and intervention and addressing vulnerabilities, and hopefully to mitigate those altogether. So it's a whole different way of thinking about it. The current approach is fundamentally a whack-a-mole approach. You get a vulnerability, you whack it, other vulnerabilities pop up, like moles. And so it's clearly a strategy that will not scale or work over the course of years and decades. And so what Symantec is doing is introducing a whole new framework for how do we address vulnerabilities at a scale, previously impossible. And then how do we apply, hard mathematical principles towards validating this in real environments.
Yeah, you answered one of my next questions was about the use of AI and being the double-edged sword that new technology represents in terms of cybersecurity. To what extent now are you using AI? How far along that curve are you?
Yeah, so we are, one of our growth segments is the use of AI to address, as I was just mentioning, vulnerabilities at a scale previously not possible. So we're literally building today large language models that we can apply to a vast amount of data in order to identify vulnerabilities and weaknesses that enable us to mitigate those weaknesses prior to their being exploited. And that's where our what we call attack annexes come into play. So we can, we can basically simulate, what a hacker or what a nation state adversary would be doing in our systems. And by doing so and utilizing, the AI to accelerate, the identification of those vulnerabilities, we can address those at a scale that is going to be increasingly necessary if we're going to stay ahead of these threat vectors and how they're evolving.
I know sometimes companies can be reluctant to share information with competitors. And they don't want to admit necessarily that they were hacked or make it public knowledge. Have you had success in getting companies to work together or work through you to identify some of the emerging risks?
The short answer is yes. We've been able to do that. And importantly, one of the novel aspects about Symantec and how we operate is that, we're a pretty large team at this point. We have, I think somewhere north of 350 scientists and engineers that we have able to deploy on very industry-specific problem sets. So we work heavily with industry, not only to identify the kinds of innovations that are needed, but then we work with industry to deploy those innovations on their systems and then use our mathematical approaches to quantify, the impact of that going forward. But inherent in all of what I just said is that we asked ourselves a very fundamental question, several years ago, and that is our job, going back to our job, what is our differentiating, feature in the marketplace, so to speak? And that differentiating feature is that we go back to those fundamentals and are developing innovations that do not exist today. And so the hard question we asked ourselves is, how are we going to develop these innovations without our adversaries learning about our approach while we are developing that approach? In other words, how do we secure our build process so that once we have products that are out there being tested, they're not immediately vulnerable because, again, our adversaries knew about what our innovations were and already developed, processes. They essentially can reverse engineer them and figure out how to defeat those. And so we spent a lot of time, and we worked with the Department of Energy National Laboratories to develop what we now call the Secure Research and Development Infrastructure, or SRDI for short. And, that all of our people, all of our innovative work happens inside of that SRDI infrastructure. And that infrastructure is based on technologies that the federal government uses to protect our nation's nuclear secrets. So it's a very, very secure environment that allows us to build new innovations and do so in a very secure way. And the reason I'm going into this in answer to that question, though, is that we can go to industry and we can demonstrate for them what the SRDI is capable of. And once they understand what that is capable of, they understand almost immediately their data and whatever machines they put, whatever people they introduce into that environment are in fact extremely secure. And that data is not going to leak and become available to not only adversaries, but in their case, they're interested about competitors as well. So that's the other reason we built the SRDI, was so that we could, in fact, work with companies on, very sensitive intellectual property, very sensitive new product designs, and so on. And, without getting into names, I will share with you that we've got multiple industry projects underway right now where we're introducing secure defensible architectures onto energy control devices, into 3D printing operations, and several more. And some of the companies that we're doing that with are all of your listeners would recognize by name immediately. They're huge players in in a global way, and they're eager to work with us because, again, we can do so in a way that not only adversaries won't be able to access the data, but their competitors can't access the data. I hope that helps.
We talked a lot about the risks, the vulnerabilities, and some of the strategies that you're taking to mitigate that. I was wondering if you could share some success stories, and obviously you may not be able to name companies by name, and it could be difficult to quantify stopping something. But you always hear about when something happens, but as you mentioned, just preventing it from happening is even the best outcome.
Yeah, I can give you several examples of. We're still fairly young as an institute, but in the last 18 months. We've issued what are called RFPs, or requests for proposals, to implement our innovations on, factory floors and factory supply chains. And industry responds to those opportunities. And then what we've got right now is we've got, somewhere around $7.5 million that we are using to fund these what we call industry use cases, and the companies that we're working with range, from a small manufacturer. One company is less than 50 employees, up to global original equipment manufacturers, or OEMs. So we run the gamut of that. A lot of times these, what are called SMMs, or small medium manufacturers, they're doing some pretty innovative work, and so we wanted to earmark some of our funds, to work with startups, if you will, or maybe not startups per se, but smaller companies that are introducing some pretty cool technologies. But we also wanted, to work with, the global players. And so we're running a gamut of those. A couple things I can point to, we went in with one of the things that we haven't talked about yet is that, for companies to invest in a level of cybersecurity that, is needed, it's expensive. And so, one of the things that we focused on is how do we decrease that expense. And while it's difficult to reduce the upfront costs, it's relatively approachable to address the recovery of cost after that initial cyber security investment is made. And so what we've been able to do is, we've worked with a significant oil and gas company, for instance, and we've introduced secure defensible architectures, and we've modeled, again, back to our fundamental math and physics, which I won't go into the details of course, but, we've been able to introduce cyber innovations onto this oil and gas platform. And what we've been able to demonstrate is that they can lower their energy cost with those cyber innovations that increase their cybersecurity posture immensely, but they also decrease their energy utilization by over 18%. And so when you do the very simple math on that, the $2,000 investment they made in securing their infrastructure resulted in multiple thousands of lowered energy costs. And we're doing the same thing for productivity increases. So how do we introduce cyber innovations, but do so in a way that's always connected, not just with, crossing our fingers and hoping the bad actors don't get in, but how do we actually quantify for the potential investor, what did you glean back in terms of your energy efficiency, your cost savings, so to speak? How did you reduce your scrap metal production? How did you increase your productivity? And we have, in fact, developed very sophisticated models that allow us to show you in real time, or show the manufacturer in real time, here's what we're going to do that's going to fortify your cybersecurity, and here's by how much it's going to do that, but here's how much your productivity increases. So we're always thinking back to, how do we really make an impact at the industry level? Because, at the end of the day, the CEO is always going to, and necessarily so, to question, just a black hole in terms of cyber investment, right? And so we have to be able to show productivity increases. We have to be able to show energy cost savings that are linked directly to these cyber innovations that we're introducing.
Just so I have it straight, by reducing your energy costs or energy savings, you have fewer suppliers that outside suppliers that you're working with, and become more secure in your supply base. That's how you become more cyber secure.
Well, that's one way. It's a little more complicated than that, and we'd have to go into a specific use case in order to really get the details there. But one of the technical innovations that we're introducing. So we've got half a dozen now patents around some of our innovations, and one of those patents is around what we call the cyber physical passport. And the CPP is essentially a new technology that allows us to track every movement of a potential part through a supply chain. So we've been able to digitize all of that and put it into an immutable notebook, so that once a part, if you will, is delivered to an OEM, so imagine a assembly of a jet engine, right? That's going to have thousands of parts and components that go into it. So how does that manufacturer trust their supply chain? So what the CPP enables is a process that we can implement and have implemented, where we can demonstrate that, once that part arrives into the manufacturer's floor for assembly, that manufacturer knows every place that part has been, and every specification from the original design to the delivered product or part, at the manufacturing site. And so for the first time ever, we can think about supply chains that are where the parts are what we would call born qualified, and where the entire supply chain is rooted in trust. And that's been something that's not been attainable until now, and that, we have multiple forms now of the CPP that we're, again, working with industry to identify how secure their supply chains can really become once these CPPs are implemented across the board.
One thing that we haven't talked about much yet is, no matter how advanced technology becomes, there's still the human factor, and people interacting with these technologies and managing them and using them. How is Symantec working with in terms of workforce development? Where does that fit into your mission?
Yeah, so thanks for that. Workforce development is a huge part of our mission. While we are, as an institute, focused on developing new technical innovations, it is imperative that we upskill and reskill the workforce in cybersecurity. So if you look across the United States, there are somewhere around 12 to 13 million manufacturing workers. And you think about, let's just take, in today's world, right? And since, the early 2020s, the most common threat that's been actualized against U.S. manufacturers is ransomware. It is by far and away the number one, threat that manufacturers face day in and day out. And if you look at ransomware in particular, especially again today, what you quickly learn is that over 80% of ransomware attacks are enabled because of the human in the loop. So a human somewhere in the supply chain, somewhere in the manufacturing process, is doing something that enables that ransomware attack to happen. And, the consequence of that is enormous. The cost to the manufacturing industry is, estimated to be in the high millions and millions of dollars. And we don't see any stoppage or slowdown in that at all. If anything, like most attacks, attack vectors, ransomware is going to get more sophisticated, especially with the use of AI to make those attacks more believable to, again, that human in the loop. So we have an extensive focus around workforce development, both today and in the future. And so there's, in today's world, like I said, over 80% of ransomware is caused by the human in the loop. So by training that human at a scale, that is meaningful. And so what I mean by that is we're not doing tens, we're not doing hundreds, we're not doing thousands, we're doing tens of thousands of training sessions and trainings of human beings in that environment so that they understand their actions that lead up to, these ransomware attacks, and thus provide a powerful, protection for a company. And right now, if you get to us soon enough, we're doing all of this training for free. Obviously, that's got to change at some point, but right now, we're running, for instance, a pilot project along with a sister entity called the Cyber Readiness Institute, a pilot project on how do we upskill and reskill, manufacturing workers in large regions across the United States. But in the future, as we develop these secure defensible architectures and these CPPs or cyber physical passports, it's going to be critically important that the manufacturer workforce understands what these technologies are and how to use those technologies. So as we grow into our future, we will be building in, advanced training, past just how to prevent ransomware, but into how do we use secure defensible architectures to increase productivity? How do we use CPPs to verify, the resiliency and security of a supply chain? So that's kind of where our vision is into the future.
And is the training, across the board, line workers, managers, IT managers, designers, engineers, executives, or are you focusing on specific groups or?
All of the above, to be honest with you. So we've developed what we call a learning management system that you can access on our website. And in that LMS, you will find training for, as you said, line workers. You will find training for the cybersecurity officers at in manufacturing companies, and you will find training for C-suite individuals, understanding that the training target there is different because if you're in the C-suite, you need to understand the investment strategy. A line worker may not need to understand that at the same level, and vice versa, right? So, but yes, we are focused not just on the person on the floor, but we are focused on the person making cybersecurity decisions, and we're focused on those individuals that provide the resources to the implementers and the workers as well.
And I imagine the training would range depending on who the person is and what their job is, from a couple hours to a week or more, or?
Yeah, so it depends. I mean, a lot of our training is you just a few hours. Some of our training is somewhat higher than that. but we've made every effort to make all of our training modular so that you can take it off, if you will, in bite-sized chunks. You don't have to commit, 3 months of your life, 2 hours a day, to this. You can kind of pick and choose what's valuable to you going forward. We've been very cognizant of developing our materials with maximum flexibility for workers, for decision makers, for resource allocators, et cetera.
So you've been around for 4 or 5 years now. Any new initiatives or programs that you're rolling out this year that our listeners should be aware of?
Well, we will continue in the immediate future, the next couple years, to introduce our innovations to companies and corporate environments via an expansion of our industry use cases. So that's one thing that I think to very much keep in mind. If you look down the road, at our strategic initiatives over the next 6 to 7 years, we seek to do fundamentally 5 things. First thing is, cyber secure the digital interstate that interconnects the manufacturing ecosystem. And what we mean by that is that, increasingly data and as digital threads are increasingly used, those digital threads are going to be accessed by multiple companies, not just by a single company. So how do we secure that digital interstate? And how do we help manufacturers, both OEMs down to the small manufacturers, how do we access that data? How do we access those digital twins in a highly secure fashion? The second major goal that we have is, as we've talked about a little bit today, but we want to bring the full power of artificial intelligence and mathematical formal methods to address cyber vulnerabilities at a scale previously not possible. A third major objective we have, as we hinted at here today, is we want to protect and cyber secure the provenance and the resiliency of U.S. supply chains. A fourth major goal is, continuing to upskill and reskill the workforce to basically enable a transformation of the manufacturing ecosystem. So let me pause for a minute there. Many of the listeners here will remember manufacturing in a world that existed pre, safety, right? And in fact, I myself, when I was a young man, barely a man, I worked in an iron forge factory in the Midwest, in the automotive industry. That job was dark. It was very dirty. It was very dangerous, and nobody cared. Very few people cared about what happened to me, right, and my safety. And that's a different world today. If you look at a factory today, they're clean. The work is interesting. It's a much improved environment where safety is considered a prime feature. And we look to a future where, the cybersecurity is built in like safety is today into just the manufacturing ecosystem. So how do we build an infrastructure, at Symantec that enables that upskilling and reskilling of the workforce for not just tens of thousands, which we've done already, but how do we do it for millions, of workers across the United States? And fifth, and certainly not least, if you think about, the use of AI, in spite of the disruptions that, your listeners may be aware of, from the Chinese company DeepSeek, despite some of those, developments, it remains ever true that to utilize artificial intelligence in a way that the United States wants to compete globally, it's going to use a tremendous amount of power, especially in the form of electricity. So one of the things Symani is focused on is, increasing that energy efficiency. So our fifth goal, if you will, is to enable 100x increase in energy efficiency over the next 20 years. That does in large part support the expansion of AI in both U.S. manufacturing and other national security initiatives in our country. So those are, in the short term, the next year or two, stay tuned for those industry use cases. And please, share with us your best thoughts on how to introduce our innovations onto your factory floor. And then as we think towards the future, think about how we secure the data at a scale that's just literally not possible today.
Yeah, as you noted, things have changed dramatically in recent years, and even more is on tap continually. But it's great to know that organizations like Symani are working on solutions and are setting big goals like improving energy efficiency by that much over that time frame. Dr. Imes, thanks again for joining us today. If listeners want to learn more about Symani or sign up for some of your programs, where should they go?
Fortunately, we have a revamped website that we've just rolled out. So Symani, CYMANII.org, and you can link to us there. You can check into what's involved in becoming a member of the Institute. We are a member-driven organization, and we welcome your interest in joining us. Our tagline, which I haven't mentioned yet, but our tagline is "Secured Together," and that tagline really epitomizes our commitment that. And our belief that cybersecurity is a team sport. No one entity, no one organization is going to do it by itself. So we are a public-private partnership. We have partnerships with industries of all sizes, and we seek to grow our industry support over the next years significantly. We also have DOE National Laboratories as members, and we have universities as members. So I often describe the Institute as, an institute of the future. So lots of universities have lots of centers, institutes, and labs, but they're all very inwardly focused. They all have very smallish missions, if you will. The Institute of the Future, like we are, is really a broad institute across the United States. We have membership in, I think, over 30 states right now, and we seek, again, to grow that. But at the end of the day, we need our partners in order to help us test and validate those technical innovations that we do. And, go to Symani.org and, reach out to us. If you want to reach out to me directly, it's just my name, howard.grimes@Symani.org, and I will definitely respond.
Great. Well, thanks again for joining us. And to learn more about the latest manufacturing trends and hear more of our podcast, visit advancedmanufacturing.org, and be sure to like and subscribe to our feed.